All right, my friends, welcome to section 3.3, part 3. Section 3.3, part 3 is about using the rules that we've learned to find equations of tangent lines and normal lines. Okay, we are going to do one example. I believe this is example 9, and this is our last example. No, am I lying? Am I lying? No, yeah, this is our last example of section 3.3. Then we get to move on to section 3.4, or sorry, 3.5 that is. Anyway, so example 9, we'll just do 3 parts for it, and then we'll be done. And I hope everything makes sense for you. So part A, the directions are for you to find the equation of the tangent line to the graph of f of x equaling x cubed minus 1 when your x value is negative 1. Okay, so good time to pause the video and see what you would do in a situation like this. Assuming that you've done so, let's talk about the easiest way to do this problem. You officially have permission to use rules that you've learned in all of our section 3.3 videos. So what is it that we're super good at this point in chapter 3? We're super good at getting f prime of x, just using some basic rules. So in this case, that would be difference rule, derivative of a constant, and power rule. So I hope everybody's okay with f prime of x would be 3x squared. Now, let's think about what is this for. This, my friends, is a slope formula. So it isn't your slope, it's a slope formula. You'd have to put the right x value into it, though, to get the slope. So we care about the slope of the tangent line when x is negative 1. So if you want to get the slope of the tangent line, so it's let's be clear, this is a slope formula for the slope let's say just slope formula in terms of x. So if you want the slope when x is negative 1, you just have to say, well, what would f prime of negative 1 be? And then you just put your negative 1 into the rule. So 3 times negative 1 squared would be 3. So this is the slope of the tangent line to the graph of f at x equaling negative 1. So notice you use the formula, but then you need to plug a value in to get your slope of your tangent line. So now we know the slope, and we want to know the equation of the tangent line. So you need to figure out the point of tangency. So you know that the x value of the point of tangency is negative 1. They didn't give you the y value, so you could just get it by plugging it into the function. So f of negative 1 would just be negative 1 cubed minus 1, which would be negative 2. So what do we now know? We now know, according to this, that the point negative 1, negative 2 is your point of tangency. So you know you're looking for a line that has a slope of 3 and passes through this point right here. And so I'm just going to go ahead and use point slope. So our answer then would be that the equation of the tangent line would be y minus negative 2, or y plus 2, equals our slope times the quantity x minus negative 1, also known as x plus 1. All right, and my friends, unless you really, really, really love turning everything into y equals mx plus b, now that you are this far into math, we all consider this to be as good or even better than a y equals mx plus b answer. So go ahead and leave it just like that. Okay, part B, let's have this kind of absorb what's happening, and then we'll use what you do in part B to do our last part, which will be part C. So part B, let's have you draw, actually, let's just say, for short, let's just say graph F. And the tangent line equation found in part A. And I want you to graph them on the same plane. Okay. Also a note, do your best to use what's called a square scale. So try to make sure that the tick marks, the distance that's worth 1 on the vertical axis is the same as the distance that's worth 1 on the horizontal. Do your best. You can see I'm messing it up as I tell you to do it perfectly, but you know. All right. All right, so let's graph the original function, x cubed minus 1. You could t-table it in your head, plugging in 0, 1, negative 1 type stuff. Or if you know what a cubic looks like and you just want to shift it down 1, that works too. Either way. Just make that dog globbier so it looks like. Okay, so here's a somewhat good graph of F, somewhat not too horrid graph of F. And then now let's add the equation of the tangent line here. So some people think they have to turn it into y equals mx plus b to graph it. Please don't think that's true. You know that this thing hits the point -1, -2. And then you also know it has a slope of 3. So here's your point of tangency, and then you can just go up 1, 2, 3, and then over 1. You could also go down 1, 2, 3, and then to the left 1. Let's see, 1, 2, 3, and then to the left. Something like that. And then you could just draw it in. Like so. All right, so there's your picture of the original function, and then here's your point of tangency at -1, -2, and then we gave it a slope of 3, and you can see it does look like it kind of represent the curve of the slope of the graph at that place. Okay, last part, part C. Find, oops, that's not enough. Find the equation of what's called the normal line to the graph of F at the point -1, -2. And then add it to your graph. Okay, so as a lot of folks think this is going to be hard, it's not, as long as you know what a normal line is. then you should be fine. So just a quick definition. A normal line is perpendicular to a tangent line. There we go. Okay, so so I hope that makes sense. That's probably shorter than the true definition. There's some details as where they intersect and things like that. But I think if you know that, then it should make sense how to finish this out. As a matter of fact, I'm going to go ahead and break the rules here. I'm going to add it to the graph first. So the slope of the tangent line was 3. If you want the normal line to form a right angle with the tangent line, then instead of going up 3 over 1, you're going to basically need, I hope it makes sense. This is something that I noticed has been a common mistake left over from Algebra 1. I hope it makes sense if the slope of one line is positive, then the slope of the line perpendicular to it. See how it goes down as it goes to the right when the other one goes up. So, so instead of a slope of 3, you'd have a slope of -1/3. So down 1 to the right 3. And then up 1 into the left 3 so that you have this like right angle right here. So this orange one is the normal line. So if the slope of the tangent line, I'll just say slope of the tangent line is 3, then the slope of the normal line would be -1/3. Your point, so this, you could, if you want to be fancy, you could call this your point of normalcy. There we go, instead of your point of tangency. And so you just point slope it. So here's your slope, and then there's your point. So you'd have y minus -2 or y plus 2 equals your slope, which is -1/3, times x minus -1 or x plus 1. And then there is your equation of your normal line that intersects in the same place as the tangent line. All right, my friends, that is part 3. I hope you find this refreshingly short. Take care, everybody.